tools out there. BT Audit will tell you the status, will interrogate the L2 cap and PSM channels for you and let you know what's open and what it looks like. And Nmap, we can obviously run Nmap against the device, and we can use SCB tool and the HCI tools to interrogate Bluetooth devices. The P0F database, which we'll talk a lot about later, is a great signature of all what TCP signatures are out there. And we can use it to create signatures of our mobile devices. And then HCI tools will give us the host controller information on a Bluetooth device. And so, being the Army officer I am, I glued everything together with a whole bunch of Python code. And then, to do traffic generation, there's a lot of great things out there. Scapy and pyBluez, and again, P0F does traffic generation for us as well. And then logging is vital in this because we want to discover what's happening, what's being sent to those devices. And so tools like Wireshark and Kismet and TCP dump and spec tools and GPSD will all monitor different aspects of what we want to log. So our system works like this. For each device that's out there, we interrogate all of them and we build an XML profile. And it's just part of an XML profile that gets loaded up. Each different port that's out there, whether it be a TCP port or a UDP port or an RFCOM or PSM, we write specific scripts to do what that mobile device is doing in that state. And then those scripts also log all the activity. And then we also, after interrogating both the Wi-Fi and Bluetooth radios of the device, we flash all that stuff onto our radios, and then so it looks exactly like it. The DBT120 Bluetooth dongle is the dongle of choice. You can flash it with BCCD, and it will flash most of the Cambridge Silicon radios. The tool is written by Marcel Holtman and Adam Laurie. We can turn a Bluetooth radio into anything. We can turn it into a mobile phone. We can turn it into a netbook. Writing Bluetooth code with BluePy is so simple. And so I just wanted to flash it up there real quick. We can advertise a Bluetooth phone book completely and then begin logging any activity to that phone book. The Wi-Fi hardware, there's probably other USB dongles out there that do it really well. The dongle of choice that we used was the AirPCAP transmit. We didn't mind paying the Windows tax on it because some of the radios won't allow us to change the MAC OUI, and so we wanted to be able to change the MAC address OUI, and it supports traffic injection. The thing about this device is if you try to get it running under Linux, and I only tell you this because it ruined one afternoon for me, was that Compat Wireless will run as a driver on it, but in order to run as a driver, and it will run in userland, when you compile it, you just need to add the USB vendor ID to the source file. Scapy. It's so easy, even Army officers can write packet injection code. That was my best attempt at a joke. Okay, I tried really hard. I had that one in reserve. So Scapy is great because it supports all of the protocols we want to talk on. So when we want to pretend to be particular HTML traffic on TCP, we can tell Scapy exactly what we want. And it will work on both Bluetooth and Wi-Fi and IP. It will build packets exactly how we tell them to build them at all different layers. And there's a world of great reference out there. If you want to write packet injection code, and Scapy's great for it. In fact, in the process of doing this work, I came across an entire TCP finite state machine written in Scapy by Adam Pridgeon over at the Cover of Night. Absolutely amazing. So if you want to generate a 802.11 wireless packet that's a DNS reply on Scapy, you can do it in 3 lines of code just like that. All right. And this is the beauty of it. Scapy can actually integrate too with P0F, the database of device fingerprints. We can use P0F to impersonate a TCP SYN. So if someone's doing TCP fingerprinting against our device, we can pass the OS right up in the packet, and it will pass the fingerprinting check. And you can use the P0F tool to collect all those signatures as well. Mimicking users is really difficult. How they act and how they behave and what their traffic looks like and what percentage of that traffic is just malformed by nature and what percentage of it is malformed with the intent to cause harm. Here's a joke coming up. Thanks. I think I have one on the next slide, too. We can't just fire off wget scripts to kitandwar.com and I love cats and pretend to be a college student. Our traffic has to be representative of actual traffic. And so in the process, we built 4 different traffic models of what traffic behavior might look like. The joke's on this slide, if you're missing it. So top secret government agents do things like VPN and SSH, and they use PKI on. They really do. Corporate employees do things like browsing webmail and logging on and getting financial news and hidden sites like that. And university students, and this is another joke, they do things like, well, university students do. All right. So this is what it looks like together. And here's what happens. When we fire it up and we pick a profile of a mobile phone and you fire whatever Bluetooth scanner you have against it, it will come back and tell you that's a mobile phone. And if you interrogate it later and ask for its service discovery records, you'll see that it matches all the service discovery records of what that specific device is supposed to have. And so it's pretty convincing that it's an actual device. And if you scan it with Nmap or something, if you're connected to the same network, you'll see that it offers the same ports and services that would naturally be offered. Okay. So logging all of the activity becomes a challenge because any communication to the device is actually suspect. But that doesn't mean that every Bluetooth name request is bad. I mean, this happens all the time where you put out a device and it gets queried by someone trying to connect their iPhone headset. So it's going to register a lot of false positives. And so we're looking for ways to take out all the false positives in our system. Ideally, in honeypots, all the traffic to it is suspect. But when you build mobile device honeypots, there's a lot of interoperability that's supposed to be built into the system, and so it becomes naturally suspect, and you run the risk of false positives. So these are all the types of things we're logging. We're logging the entire frequency spectrum, the activity on it. We're logging access to all the transport layer protocols. We're logging all the activity to the applications. And then additionally, embedded in our traffic generation are bogus websites, and any further attempts to access those websites or different resources we're logging as well. So this is an example of a Wi-Fi packet we grabbed. We don't know if it's just a malformed packet or if it's an actual attack. Recording Bluetooth is really a challenge because right now all we can get is the host control layer information, and so that doesn't tell us a lot. With specialized equipment like we have a protocol analyzer that can pull up the Bluetooth information, the full packet dump. In a PicoNet, we can cover everything.